We will now discuss the solution to exercise 13-1. 13-1 on page 607 wants us to use the net present value method to determine whether the investment in this particular machine is an acceptable project. The management of Opry Company, a wholesale distributor of suntan products, is considering the purchase of a $25,000 machine that would reduce operating costs in its warehouse by $4,000 per year. At the end of the machine's 10-year useful life, it will have no scrap value. The company's required rate of return is 12%. They want us to determine the net present value of the investment in the machine. So the way to tackle this problem is we need to, when we do net present value, we take the initial investment less the net present value or the present value of the future cash inflows. So the initial investment today of $25,000 is an outflow of $25,000. What we need to measure or determine is we're going to receive $4,000 per year each year for the next 10 years in cost savings. So by saving cost, that is what we would call a cash inflow, all right, because we're holding on to more cash. So what we need to do for this annual cost savings, this is an annuity, years 1 through 10. The cash flow per year is $4,000 per year. We need to go to the table on page 630 in the back of chapter 13. The table on page 630 will give us the present value of an annuity, and in this particular problem our discount rate is 12% and the number of periods is 10 because there are 10 cash flows because it's a 10-year annuity, 10 years of cost savings. So if we go to table 13B2 on page 630 and you go across the top to 12% and then go down that column to 10 periods, you see the discount factor of 5.650. 5.650. That discount factor multiplied by $4,000 gives us the present value of that annuity. So in other words, this $22,600 is the present value of the 10 $4,000 payments that would be received over the next 10 years. By discounting back or bringing back those future cash flows to today's value, we learn that that $40,000 in total has a present value of $22,600 today. So when we calculate the net present value, we subtract the present value of the cash inflows, we subtract the present value of the cash outflows, and we learn that we have a negative net present value. In other words, our cash outflow is greater than our cash inflow. Therefore, with it being negative, it is not an acceptable project. Under the net present value method, projects are only acceptable if the net present value is 0 or it is positive. Therefore, the solution to this problem is a negative $2,400. When we look at part 2, they ask us to compare, all right, what is the difference between the total undiscounted cash inflows and cash outflows over the entire life of the machine. And when we do this, we find out that the cash outflows are $25,000. All right, as we saw earlier, cash inflows of $40,000, the net cash flow a positive $15,000. However, this is undiscounted. This does not take into account present value. The proper solution to answer this question would be the calculation we did in part 1 of this problem. This does it for our discussion of the solution to exercise 13-1.